Hello, in this lesson, I'm going to review the construction of frequency and relative frequency distribution for quantitative data. So this is chapter 2.2 of your textbook. Okay, to organize our quantitative data, we first divide it into ranges called classes, and usually we have about 5 to 15 classes. Now the endpoints of the classes are called lower class limits and upper class limits. The class width is the distance between consecutive lower class limits. You can also say consecutive upper class limits as well. Now, most of the time, class width will be given, but if it's not given, we can calculate it, find it by using the largest number minus smallest number, and then divide it by number of classes. And once we get a number, we always round that number up to the next, right? So we're going to use section 2.2, this is question number 6 of your homework. Now, the data below represent the number of customers waiting for a table at 6 p.m. for consecutive Saturdays at a restaurant. And this is the data below here. Now, A, are this data discrete or continuous? Again, discrete data are something that's countable and finite, where continuous data will be like for any 2 data points, it will make sense to have another number between these 2 data. So basically, another for continuous, for any 2 points, there's another point between these 2 points, which is in a continuous spectrum. So let's look at our data given here. Notice that we have 11 customers, and the next Saturday we have 12 customers. Well, let's think about it. I can count the number of customers in each day, so it's countable many, so therefore it's discrete. So the data here is discrete. Now, let's say I want to think if it's continuous or not. Let's say, think about 11 customers on a Saturday, 12 customers in a Saturday. Well, is it possible to have a number between 11 and 12? Let's say 12.5. Can I have 12.5 customers in any day? Well, what do you mean 12.5 customers? It doesn't make sense. There's no half people here, half person here. So therefore, it doesn't make sense here. Therefore, it cannot be continuous. All right. So therefore, it must be discrete. Well, that means C and D cannot be my answer, so I eliminate it. Well, look at A and B. A, the data are discrete because they are finite or countable number of values. Well, that's correct because we know it's finite and it's countable. That's how we describe discrete data. B, the data are discrete because it was recorded for 40 consecutive Saturdays. Okay. The number of days recorded doesn't change the type of data we have, so therefore B is not an answer. All right, let's use this data to construct a frequency distribution and a relative frequency distribution. Notice that I lump both frequency and distribution and relative frequency distribution together into one table. Now, frequency distribution means that in my table I should have a column for frequency. The relative frequency distribution tells me I need to have a column for relative frequency. Well, before I can construct a relative frequency, I need to do a frequency first. Okay, so let me erase that. Now, the direction given to me says the distribution with lower class limit of the first class. Lower class limit of the first class is 1, meaning that the first class is going to begin at 1. All right, and with the class width of 3, okay, class width of 3 meaning that again, class width is the differences between lower class limit for consecutive class. So to get to the next class, I can use class width of 3, the width of 3 added to 1. So 1 plus 3 is going to give me 4. So the next class begin at 4, right? 4 plus 3 is going to give me 7. So the next class begin at 7. And 7 plus 3 give me 10. So next class begin at 10. 10 plus 3 give me 13. So the next class begin at 13. Right? So those are the classes. Notice I stop at 13 because the maximum here is 15. And the next class for begin will be 16, 13 plus 3. But we don't need that for this one here. Now, these are lower class limits for the 5 different classes here. Well, let's look at upper class limit. Well, my data here are all integers, so there's no decimal involved. So I'm looking for a number for the first class, upper class limit be the number that's less than 4. The maximum number that's less than 4, that is an integer. because my data is integers. So it would be 3. So upper class limit for the fourth class is 3. Again, and the next number that's lower than 7, a maximum integer less than 7 would be 6. And 6 plus, again, next one will be 9. And next one will be 12. Next one will be 15. Now, notice that if I add, notice 1 plus 3 here gives me 4. Again, 4 plus 3 gives me 7. 7 plus 3 gives me 10. 10 plus 3 gives me 13. I can do the same thing for upper class limit. Notice that 3 plus 3 give me 6. 6 plus 3 give me 9. 9 plus 3 give me 12. 12 plus 3 give me 15. So when you add the class width to the lower class limit, gonna give you the next lower class limit, and you add the class width to the upper class limit, gonna give you the next upper class limit. All right, I'm gonna erase that. Okay. Now the next part is tally how many Saturdays have the waiting time for customer is between 1 to 3 minutes here. So I have 1 to 3. So let me erase that how I can see them. So here I notice that numbers that are between 1 and 3, this is one of them. Let's say a 3. So therefore, that's the only one number between 1 and 3. So the frequency is 1. But it's kind of difficult to look for all of them and tally them up to get the whole thing. So one easy way to do it is to enter this data into your calculator and then use your calculator to do the to count the frequency. All right, so let's do it. Let me erase that part. Oh, undo. Okay, I meant to erase the red here, not the black. Okay, so my calculator is over here. Now I'm going to put it on. Okay, so here you're going to enter the entire data set into one your listing by go to Stat, Editing. Now notice my data is ordered here already, but I'm going to show you how to order it. First, you're going to enter your data into any one of the lists here. I use L1. Right? You can enter, let's say, for example, you can enter any order you want, but make sure you enter all of them. I could say 11, 13, 11, 14, 9, enter all of them into L1. Once you've done that, then you're going to go to Stat, right? Hit Stat. Now notice the number 2 is Sort. So go click Sort, put Enter. Now you're going to tell your calculator where your data is, where you store your data. So I store my data into L1, so therefore I'm going to store L1. And so therefore I'm going to need to go to L1. Again, L1 is the number on top of number 1 here on your calculator. So get to L1 and you hit second 1. Going to give you L1. Second 2 could be L2. Second 3 could be L3, etc. And then I put enter. Done. Right? Once it's done, you go back to your stat. You will notice that your list is sorted. Right? So the list is already sorted. Okay, let me give you another example how to sort. Let's give you some easy numbers. Say -5. Let's say I don't know, -100. And then I have a 2. And then I have a 6. And then I have 100 here again. A 10. I don't know. Okay, let's say I want to sort list. Okay, let's take an example. So sort them. I go to stat. Okay, go to number 2. Use the arrow to number 2. Hit enter. Now I'm going to count my calculator, sort list 2. So second 2, give me list 2. Close. Enter. Now list 2 will be sorted as well. Okay, stat. Let's check them. Editing. Notice that list 2 is sorted. -10, -5, 2, 6, 10. It's just some random number here. Okay. Well, our data is in L1, so I'm going to count my frequency. Let's finish that table. Now notice that the fourth class is number 1 to 3 inclusive. So there's only one of them, therefore frequency is 1. The next class is 4 to 6. So let's count how many numbers between 4 and 6 inclusive. So there's 1, 5, 2, 5, 2 5s and 2 6. 2 6 here. So therefore frequency is 4. So therefore second group is 4. You can do the same thing for the next class and the next class as well. All right, let me fill it out. So second class, okay, second class is 4. Okay, somehow my, going down too far. Okay, so second class is 4. Again, you can go back to the calculator, get to the next list, which is 7 to 9. And when you count, there will be 13 of them. But okay, let's do it. Try one more time. So I want a number that's less than 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Notice that 13 number that's less than 9. So the next frequency will be 13. You can do the same thing for the next one. You will get 15. And then next one will be 7. Okay. So that will be my frequency. Now, when you total it up, you should have 40 data points because I have 40 consecutive Saturdays, so you have 40 data points. So total here, you add 1 plus 4 plus 13 plus 5 plus 7, you're going to get a 40. Okay. Next one is relative frequency. Relative frequency is given by frequency over the total. And here, I'm going to keep 3 decimals. So let's see. So first one is 1 over the total, which is 40. And use your calculator, you will get 0.025. And then 4 over 40 will get 0.1. 13 over 40 will get 0.325. And then 15 over 40 will be 0.375. 7 over 40 going to give me 0.175. And when you add the total together here, you will get a 1. And relative frequency total always add up to 1, or in other words, 100%. Now let's use this table to answer the following questions, part C and D. All right. Part C say, what percentage of Saturdays have 40 or more consumers or customers waiting for a table at 6 p.m.? Okay, percentage of Saturdays. Again, notice I'm looking for percentage, not frequency here. So percentage, and that is on a Saturday, and 4 or more. Okay, first let's look at classes here. Notice I copy and paste the table over here. That's the previous table, the same thing. So 4 or more, let me locate the number of customer. That's 4. 4 or more could be that's everything from 4 to 6 to 7, 12, all the way up here. So basically, that's all the numbers in the last 4 classes. That is corresponding to relative frequency. This all relative frequency here. So I'm going to add up the relative frequency and going to give me the proportion of customers that have 4 or more. Then I convert that to percentage afterward. Okay, let's do it. So 4 or more is corresponding to 0.1 plus 0.325 plus 0.375 plus 0.175. And when you add them all together, we'll get 0.975. And to convert that to percentage, I multiply 100, which is going to give me 97.5%. Okay. Now, another way to get the same answer is to use the complement. Notice that 4 or more is the last 4 classes. The only thing that I'm not counting is the 4th class. So therefore, instead of adding the last 4 classes, I can also use 1 minus the 4th class, which is 0.025. Also going to give me 0.975. And in chapter 5, we're going to talk more about complements. Now I'm going to answer the question in a complete sentence. Always do. So I say the percentage of Saturdays have 4 or more customers waiting for a table at 6 p.m. was 97.5%. All right, write it out here. Here I'm going to skip the writing to save time. Part D. What percentage of Saturdays have 12 or fewer customers waiting for a table at 6 p.m.? Okay, let me erase that again. I want 12 or fewer. Let me find 12 first. 12 is right here. 12 or fewer, meaning 12 or less, so everything before 12. So that means I want to count the sum of the first 4 classes. So meaning I'm going to add 0.025, 0.325, 375 together to get the answer. Okay, so let me add them. So we'll have, again, a keyword here, percentage, that's why I have relative frequency. So I'm going to add them is 0.025 plus 0.1 plus 0.325 plus 0.375. And when I add all this together, you get 0.825. And convert it to percentage by times 100, which is 82.5%. And that will be my final answer. Again, make sure you answer the question in a complete sentence. I will say the percentage of the Saturdays have 12 or fewer customers waiting for a table at 6 p.m. was 82.5%. Okay, that will be using a relative frequency to answer questions here. Now, let's construct a frequency histogram for the data. Okay, notice that I want a frequency histogram. That means I'm going to use the column for frequency. Let me erase that. So I'm going to using the data in this column here. Notice that my maximum here is 15. And my minimum here is 1. So I could begin at 0, maybe for the increment of every 2. I could do 2, 4, 6, 8, 12, 14, 16. I can also do increment of 3, so it will be 0, 3, 9, 12, 15, 18. So I notice that if an increment of 2, I will have too many dots, too many tick marks. So I'm going to start with increment of 3, so I'm not overwhelmed with too many tick marks. Okay, so for more detail on how to scale a number line, please watch the video for integrated review, scaling of a number line. All right, let's do it. So I'll begin at 0. I'm going to begin at 3, increment 3, and then with an increment of 3. So 3 plus 3 going to give me 6. 6 plus 3 going to give me 9. 9 plus 3 is going to give me 12. 12 plus 3 gives me 15. And my maximum is 15, so I don't have to go any higher. Now for the that's a vertical axis, and that is my frequency. Let me label it. Now in the horizontal axis is the number of customers waiting at 6 p.m., which is the classes. All right. So my classes, and I'm gonna have to label the horizontal axis with a lower class limit. And notice that my lower class, the first class, begin at 1, not 0. So I'm going to tell my customer, I'm going to tell my reader here, I'm not begin at 0 here. So I'm going to start at 1. And the next number is 4. Right? I'm labeling within the lower class limit, meaning that I'm using 1, 4, 7, 10, and 13 to label my points. And I can add one more, become 16. Because, right? So let's do it. So the first one is 1. Okay, lower class limit, first class. The next lower class limit for the second class is 4. 1 plus 3 give me 4. So that would be my 4. All right, and the next one is the 7. 4 plus 3 give me 7. 7 plus 3 gives me 10. 10 plus 3 gives me 13. And I know that my maximum here is 15, so I want to include 15 on it. So plus 3 gonna give me 16. Okay. So that will be my lower class limits. And this is a number of customers. This number of customers waiting at 6 p.m. All right. Now let's make the frequency. The first class is 1, have a frequency of 1. So I'm going to draw up high to 1. Let me use the red here. I'm going to use blue here. 1, and that is 1 right here. I think this is 1. Now high at 1. Now I'm going to make my bar. Okay, 1. This is 1 to 3, so less than 4. So I'm going to draw the horizontal axis all the way to 4. Okay, that represents the first class from 1 to 3, not including 4 here. Remember. And I can shade my bar here. Okay. I can also write a number on top if I like, 1. The next is 4 to 6, not including 7, that is 4, frequency of 4. So I'm going to go up to 4 here. That means 1 over 3, a little bit over 3. Okay, and I'm going over to 7, and that is 4 to represent a class 4 to 6, and a frequency of 4. Okay, the next one is 13. So go up to 13. Okay, so 13 maybe a little bit higher. Okay, and 13. Okay, make sure you scale them correctly. My bar here look a little more big. So again, it's important actually to scale them correctly. And I would suggest use a ruler to do it. And that is the next bar. I'm gonna shake and fill it in. Just make it look a little nicer. And the frequency here is 13. The next one is 15, the highest one. Okay, 15. Okay, and then I'm gonna fill it in with and with a frequency of 15. And the next one is 7. And 7 is a little bit over 6. I would say 7, 1, okay, over here, 6, a 7. Frequency of 7. Okay. And that will be 7 right here. And that completes my histogram. Okay. Notice that there's no gap between each bar here. Let me, I would say fill it in and make it look nicer. Alright, I hope yours look nicer than mine when you make it. Alright, that's finished my frequency histogram. Now, the next one is I'm going to construct relative frequency histogram. Now, the horizontal axis will be exactly the same. The difference is the vertical axis. Instead of using frequency, the vertical axis, we should use relative frequency. Okay, so let me just how you label the frequency, the vertical axis. Now, I noticed that the vertical axis here, it begins with the maximum number is 0.375, close to 0.4. Okay, so I noticed that each one is close to 0.4. Let me highlight it. Maximum here is about 0.4. So I'm going to scale my vertical axis so that it's been 0.4. I could do 0.1, 0.2, 0.3, 0.4, and then divide each one half further. So let's do that. So I'll say this is my total, and I divide in half again. And each half I divide half again. So the maximum is on my relative frequency here is 0.375. So I can make 0.4 be good. So this is 0.1, 0.2, 0.3, 0.4. I can make my graph more precise by adding half in between again. This will be 0.05. This is 1.5. That will be 2.5. That will be 3.5. Okay. And this is this will be 0. And that is my relative frequency. Label them. And on the horizontal axis, we do the same thing as before. We're going to label using lower class limits, which are 1, 4, 7, 13, and 16. All right. Again, I'm not begin at 0 here. So first one's 1. Okay, and the next is 4, lower class limits only. And the next one is 7. And the next one is 10. And next one is 13. And we always want to add one more. So they include the maximum of the next one. The next one, maximum here will be 16. Okay, now notice I'm a little bit outside of my bar here. Let me extend it a little bit. Oh, let me use the eraser and redraw it. Okay. And let me extend this number line. And So now that it's very important to actually use a pencil to do it, because you'll notice a little bit things here you need to add and erase. So that will be how you set up. And then horizontal axis, notice we're still the same, will be a number of customers at 6 p.m. Number of customers. Now, I'm going to graph it using relative frequency. Now, the first class is 0.025, right? 0.025, remember this one here is 0.05. 0.025 is half of 0.05, all right? So, my first class here is going to be halfway there. Let me change my eraser. Okay, so again, this will be half of that, 1/4 of the total here. So, it will be 0.025, it will be right here. Okay, and my bar. You can also put the relative frequency on it if you like. So 0.025. Right. The next one is 0.1. And I put it over. Okay, that's 0.1. Yeah, maybe a little bit higher. Okay, that is 0.1. And the next one is 0.325, about 0.33. Okay, 0.33. So let me go up to 0.33. And it's happy under 0.35, so 0.33. Okay. And then horizontally. And here on the paper, I would suggest you use a ruler or a straight edge to make it, so that way it's more nicer looking. Okay. Okay. And that one has a total 0.325. I put a number here. You don't have to. I just put a number. It's easy to read. And the next one is 0.375. Okay. 0.375. That would be, okay, over here, under 0.4. Okay. And then I draw my bar down. So 0.375. And the last one is 0.175. So 0.17, approximately 0.18. Okay, so 1A will be this 0.2 here, will be 5 approximately here. Okay, 0.175. That's it. That is relative frequency histogram. Notice that, let me zoom in so you can see the whole thing. Notice that the shape doesn't change. Notice that my data is somewhat skewed to the left. So it means there's some customers here on the left here. The highest bar is also highest bar is from 10 to 13. Same thing here. The shape doesn't change. Kind of skewed, a little bit skewed to the left. So that is using that's a constructing histogram and a relative frequency histogram using the table here, the distribution here. So this finishes our lesson for construction of histogram by hand. Now, in the next lesson, we will use a calculator to construct this histogram. Thank you for watching. I'll see you next time.